Hey y'all, welcome back. We are here today to talk about something that I found that's really cool. It's called the Analog Discovery 2. This little kit's available on Amazon and I believe from the manufacturer's website for right at $420. So while it's not super cheap, it's really cool for what it does. And the main thing that makes it great for us is there is some freeware called the Analyzer Suite that somebody's written to use this device for on audio gear that tracks all kinds of cool stuff. It'll show us THD versus power. It'll show us the frequency response of the amplifier. It will show us the THD versus frequency. And it does some other stuff that, like IMD and some phono stage stuff that I haven't played with yet. And I think you have to, wire it up a little differently than what I'm using. But it's really cool. And understand though, this is not like science lab quality measuring. That it's not going to be the replacement for like a HP audio analyzer that costs a couple of $1,000s. But what it does provide is access for hobbyists to measure their equipment versus other equipment. And it's also very good for like making a change to a piece of gear and then seeing what the difference is. It's kind of like, car dynos especially like the ones you drive on. The numbers aren't perfectly accurate from one to another or from one location to another. There's some variations there, so the numbers aren't like what you focus on. You focus on like what the change is between tuning and doing things, and it does give you a really good idea of like where the amp stands as far as how much distortion it has, and where the distortion is you can see the second and third harmonics and things like that. So it is very useful for what we're going to be using it for. Just don't expect that, like it might say 1.2% distortion and measured on a scientific lab quality machine it might really be 0.8. And I've read online people measuring the distortion that comes out of the signal generator in this little kit is about 0.1% distortion, which is going to get amplified by the amplifier itself. And so I have a feeling that the distortion readings are probably a little higher than what the amp actually has. But for $400, you're getting a whole lot of measuring ability, especially with this freeware software. I haven't even tried the waveform software that comes with the product. I just went straight to using this audio analyzer suite. You do have to download the software from the manufacturer, as the freeware uses the DDLs that activate this kit. And so go to I think it's Diligent. Yep, Diligent. Go to their website, download waveforms, and then I will provide a link in the description of where to download the audio analyzer suite. So, device under test today is going to be our little Noob Sound 6P1 that we've modified. It's got the Soviet tubes, it's got some nice 6S and 7s in it, and we're going to use it as kind of the test dummy today for showing you how this thing works. So, let's go into what exactly do you get in the kit. So here's the kit that we're talking about getting, and it comes with the device. It comes with a BNC board that has 2 outputs and 2 inputs. It comes with 2 test probes and some other little clip things that honestly I have no idea what they're for, but we're not worried about that. It comes in a nice little cardboard case that is, it is cardboard, but it's actually fairly good for storing it in. Got a little sleeve. Then it opens up, and then in this side is the device itself. It's in a protected case, and we'll go over this cord in just a minute. It comes with 2 oscilloscope probes that have a 1x and a 10x adjustment on it, just like most do. And these open up to get the little clips to clip on. Both have negative leads. Comes with the USB cord, which is what powers it up and transfers the signal to your laptop. It also has a 5-volt external transformer port, and you have to read the instructions about at what point you would need to use that. I haven't found any need to use it for the amplifiers I'm testing. Possibly on some higher power ones you would need to be able to have the signal generator put enough voltage or current into the amp that you're testing. Here's the little BNC board. Again, it plugs into the unit, and then it has 2 BNC connectors on each side. And then the device itself comes in a little protective case like this, and you pretty much have to tear that little piece to get it out. And here's the little device. It's a little pocket-sized USB powered thing. This thing doesn't require a lot of horsepower from the computer. It can operate on a fairly, the one I'm using is an old Lenovo ThinkPad that I've had for probably 10 years running Windows 7. It's got plenty of power to run this setup. And then the cord that it doesn't come with that you need to get, I got mine off Amazon, but you can get it, different places. You want a BNC to male RCA, and then you need a female RCA Y splitter that terminates into 2 male RCA plugs. So you're converting the single BNC output from the signal generator of this device to both inputs on the amplifier, and then the 2 channels on the output are connected to these oscilloscope leads. And I'll show you how you connect everything up here in just a minute. And then the other thing that you're going to need is some sort of dummy load that matches the impedance of the output of the device under test. All the amps I build, I use 8 ohms because that's what my speakers are rated at. Even though they probably are more like 6 ohms, we use 8 ohm loads for testing. And I got these little aluminum guys. I can't even, they say 100 watt on them. So they should be able to handle anything I'd ever test. You can probably get away with, lower wattage ones like 20 watt ones if you're just testing small SE amplifiers. But I went ahead and got these because they just, they come with leads on them. And I've bent these over and then soldered these leads so that they don't fray every time that I connect them and disconnect them. And it gives you want a fairly long thing here so there's enough room to clip the oscilloscope lead to, or clip the little alligator thing to when it's connected to the output jacks on the amplifier. So next I'm going to show you how to hook this thing up to your device under test so you can test stuff. Okay, now we're going to show you how to connect the device up to your amplifier. It's really quite simple, but I'll just go through it anyway. These dummy load resistors have no polarity. So you hook one up to each output and leave enough wire sticking up so you can clip the leads onto it, enough bare wire there. And then connect the negative. Connect this positive. Just make sure you got them pretty snug. You never want to run a tube amplifier without some sort of load on it, especially if you're running a signal through it. It can create voltage spikes in the output transformers that will arc out, and then once they arc, they're done. So the next thing you do is you get these little oscilloscope leads and you pull this back and you hook that one to the positive and you hook that one to the negative. Then you do the same thing on this side. Oop, that one's not. Needs to be snugged up a little bit. You hook that one to the positive and that one to the negative. And then you get this this BNC with the Y splitter, with the RCA Y splitter. And then, honestly, it doesn't matter which one of these go where, but I usually go ahead and just match the colors anyway. And that's it. That's all there is to connecting it to your amplifier. So then, now I'm going to show you how to hook everything up to the Analog Discovery 2. Okay, so we have our Analog Discovery 2 unit and our BNC adapter board. And all you do to connect these two is you put this in with the black into there, plug it all the way in, and it's got little feet here that kind of hold it all level, so that's kind of nice. Okay, the next thing you do is you find the two BNC connectors that are coming off the channels, and it'll be marked CH1 and CH2. And so these are where you connect the channels up. And honestly, it really doesn't matter which one you connect to channel 1 and channel 2, unless you just really want to be kind of anal about it. So I usually don't worry about it. But this is the important part. When you connect there's M1 or W1 and W2, and you want to connect it up to channel 1 for the signal generator. So make sure you connect this to channel 1 on this side, and then, or W1, and then CH1 and CH2 are hooked to the outputs. Then you have the USB cable, and this is a older style that is, it's not like a USB-C. There is an up and a down, and you want the flat side up, and it plugs in right there. And then you plug the other side of this into your laptop. And that's all there is to hooking up the amp to get ready to test it. So it's actually really simple. So here's what the suite looks like when you first open it. And as you can see across the top here, we have the THD as frequency, and the THD versus power, and the frequency response. And these are the three main tabs we're going to be working with. We have distortion. You can pick THD plus noise, THD, or the second and third harmonics. And these can all be selected after you do the sweep to see what the different things are. In the settings here, you want to pick a wattage that's maybe about half of what the amp can produce to make sure that you're getting about where you would normally be listening to the amplifier. And here's the 8 ohm load, and the range is from 40 hertz to 20,000 hertz, which is the range of the speakers that I'm using. We could bring this down to 20 hertz. I think that's the default, so we'll go with that. On the THD versus power, I have it stopping at 10%, so you can easily see when the THD is spiking, which is normally where the amp really starts clipping hard. Again, we have 8 ohm load set over here. Have it in 20 steps. And this is the power range. And I have it stop at 10 watts because nothing I have built so far reads that or has that much power. And then in the frequency response, we're going from 10 to, I'm not sure why it's at 50. We'll make it 20K. And Well, actually, let's leave it at 50 so we can see the roll off on the top end. And again, 50 steps. We have 5 dBs at the bottom and or the top and 10 at the bottom. And we're going to measure both channels. So this is the first test we're going to run. So you just click run and sit back and let it do the measuring of your device. I will say it's very important to let the amp warm up for about 5 minutes before you start making pulls on it to make sure that you're getting a good response from what you're testing. As we all know, tube amps need to be warmed up a little bit before we really start making pulls on them. Now again, note these are how many dBs down it is, but this amp's got a pretty flat response rate. As you can see at there's 20 hertz all the way up to 10K. It's flat as a pancake. There's a little bit of difference from one channel to the other, but it's not anything that's unusual. And we are talking about a very small amount of roll off here. So, not something that I would be super concerned with. There's not a whole lot of music in this range anyway, and honestly, my hearing pretty much is dead past 10K, and so I'm not going to hear anything up here anyway. Maybe if you got younger, better ears, you'd be really concerned about this little range, but again, not a whole lot of music happening in this range, even though people seem to be really concerned about, oh, it's got to go to 20K hertz. Most people can't hear anything up there, and there's no music playing up there either anyway. So the lamp's got a really flat frequency response range, I feel, and it shows it when you listen to it. It also, it's a little squeak on the bottom end, and it's a little on the bright side, and this frequency response range shows that it's a little stronger up here than it is down on the lower end. So let's see how the THD, and we're going to measure both channels, and we're just going to pick THD and do a pull on it. And we're down at 0.1% distortion. It's tracking the input almost exactly, and right at 1.3 watts, the distortion takes off. And that's pretty much what we measured as the clipping point. You could maybe listen to it. That's 4% distortion. That's starting to get pretty high. And from there, it just skyrockets. 2.6 watts, it goes off the scale. So it really is like a 1.3 watt amp that below 1% distortion. And obviously that's a lot less than they're advertised at. And before it was modified, the distortion happened down here at a half a watt. And so this shows you what the amp is actually capable of putting out. So if you get some really efficient speakers that are over 92.3 decibels per watt, this little amp will deliver all you need. Got inefficient speakers, this is not the amp for you. So let's do the THD versus frequency pull. And I'm expecting with this small of transformers that it's probably going to have more distortion at the low end. But let's see what the analyzer shows us. And down here in this lower window, it's showing the second and third harmonics and how they relate to the primary tone that's being injected into the amp. And I was going to make you watch it generating the curve, but as you can see, once it's generated the curve, you can scroll this cursor along and you can see in the lower left screen the harmonics at each measuring point. And as you can see, once you get to about 100 hertz, we're below 1%. And there is a little difference in the two channels, which isn't surprising, but they track fairly close together. And seems like a pretty flat curve to me. Obviously, like I said, we've got a little higher distortion here on the low end. And, you know, around 40 hertz, we've got right at 2% distortion, which for a tube amp doesn't bother me. Like I said in another video, part of what makes a tube amp sound good is the distortion. And I'm not real concerned about anything under 2% in any of my amps. And actually, some of the amps that I like the sound of have a little higher distortion. I mean, this amp sounds pretty good, but it doesn't sound real tubey like my 6SQ7 EL34 amp does. And it does show a little higher distortion across the board than this amp does. But to me, it sounds better. Okay, if we switched over to our analog gear with our trusty 2235 Tektronix scope with our TEMA signal generator, and we're going to compare the results to what we saw on the audio analyzer suite using the Analog Discovery 2. So, and I will say that suite did act kind of weird when I was messing with the volume control. So it really doesn't give you the control you have using an analog scope and an analog signal generator where you can adjust things in real time and look at them. So I really don't feel it's a total replacement for this old school gear. But if you can only afford one or the other, it probably makes sense to get the Analog Discovery 2 and then later get this analog gear. You can pick up one of these 100 megahertz Tektronix scopes for a little over $100 on eBay, and there are various signal generators that you can use with it. I got this little TEMA with a knob on it because I just like the feel of the old school stuff. But I know that there's digital signal generators, and you could potentially use the signal generator that's built into the Analog Discovery 2. I haven't played around with the software that came with the Analog Discovery 2. There may be a better functioning scope using their waveform software. That's something you can play with. But given I've got this, nice working analog scope, that's what I'm going to use when I want to just measure the scope patterns. So anyway, let's get into seeing how accurate the measurements were. Again, this is 1.1 peak to peak in 1 kilohertz sine wave, which is 0.4 volts RMS. And as we turn the volume up, we can see it's just on the verge of clipping. And if we turn the input signal a little more, we can definitely see it clipping on the bottom part of the waveform. And we have this on 2 volts peak to peak with 0.5 volts per division in. So we're getting right at 8 volts peak to peak out into an 8 ohm load, which comes out to being just a little over 1 or right at 1 watt, which is right where we saw the distortion levels starting to climb in the audio analyzer suite. So it looks like the measurements are pretty accurate. And again, this is the modified amp. Before we did the modifications to it, it was putting out about half this power. And they claim it's a 6.5 watt amp. It's not even close to that. On a good day, this is putting out just a little over 1 watt cleanly. But it is a nice sounding amp with a flat frequency response and can be bought at a fairly reasonable price. If you've got real efficient speakers, this is maybe all you need to enjoy some tube audio. So we're going to wrap this part up and do a quick conclusion on this video. Well, the last thing I wanted to go over was my analog test gear. And this is my old 100 megahertz Tektronix scope. This is my little TEMA signal generator. I say little, it's pretty big. It's got a frequency knob here. It's got attenuator click switch here. It's got, this is the voltage knob that turns up and down the signal strength. And then it's got push buttons here for the different frequency ranges that the knob works. So very analog, very knob centric, which I like. This also has, analog knobs for adjusting the position of the traces. I normally have one probe hooked up to the output of the signal generator. So that's usually my upper scope pattern. And then I have one channel of the output hooked up to the other channel of the scope with my, my two dummy loads always connected to an amp when I'm testing it. So I do feel that both of these have a place. I'm enjoying the Analog Discovery 2 with the audio analyzer suite. It's given me things that I can't measure with a scope, like total harmonic distortion and frequency response. You can sort of get an idea of the frequency response by changing the frequency on the signal generator and looking at the output on the scope and seeing if the output goes up and down with the frequency, which obviously you don't want to see. But it's nice having something that gives you a nice 3D or 2D graph where you can really look at the frequency response and see what you're getting out of the amp. If you're going to really get into this as a hobby, these are some great tools to have. And for, $600, $700, $800, somewhere around in that range, you can get an analog setup and the computer setup, which is cheaper than even a single old school audio analyzer like one of the HPs, and it's just more fun to work with. So hope you've enjoyed this video. If you like my videos, please subscribe to the channel, like the video, and we'll see you soon as we dive into building and modifying tube amplifiers.